Welcome to Case Vault, where every case has a crack, a contradiction, a missed clue, a detail that should not be there. Today we're looking at the killer who beat the world's first DNA dragnet by sending another man to give blood in his name, and the one thing the people closest to it never noticed. Leicestershire, England. Two girls, 3 years apart, both 15 years old, both walking home along a quiet footpath. Neither one made it. The man who killed them did something no killer had ever done before. He beat the first DNA manhunt in history. The police asked thousands of local men to give blood. The new science could read a killer straight off a single sample, and it cleared him. It cleared him because the blood wasn't his. He had sent another man to give it under his name. A stand-in, a substitute. The science was flawless. It just never tested the right person. What finally caught him wasn't the lab. It was one sentence said out loud in a pub. Start in November of 1983, in a village called Narborough, a quiet place. 3 small villages, fields and footpaths, everyone half known to everyone. A 15-year-old girl named Linda Mann sets off to a friend's house one evening. She takes a shortcut down a deserted path the locals call the Black Pad. She never comes home. The next morning, she's found on that path. She has been raped and strangled. The police have very little to work with. No witness, no weapon, no name. They have one thing recovered from the scene, a sample of the killer's semen. In 1983, that sample can tell them the man's blood group, and not much more. It matches a type shared by a huge slice of the male population. It points at thousands of men and singles out none of them, so it isn't enough. The case goes cold. For nearly 3 years, the man who killed Linda Mann walks around those same villages, past her family, past the police, free. Then it happens again. July of 1986, the next village over, a place called Enderby. Another 15-year-old. Her name is Dawn Ashworth. She takes a footpath shortcut home one afternoon and doesn't arrive. 2 days later, her body is found near a path called 10-Pound Lane, hidden under branches. She has been attacked the same way as Linda Mann. Same age. Same kind of footpath. Same kind of attack in villages a short walk apart. The police are now almost certain they're hunting one man. And they think they have him. A local 17-year-old who worked nearby had behaved strangely and seemed to know things about the scene he shouldn't have. Under questioning, he confesses to killing Dawn Ashworth. On the face of it, the case is closed. They have a body, a scene, and a confession. But there's a problem. He confesses to the second girl, and only the second. He flatly denies killing Linda Mann, the first one. The police are sure the same man did both, so they need proof tying this teenager to both murders. And there happens to be a brand new way to get it. A few miles away at the University of Leicester, a geneticist named Alec Jeffreys had stumbled onto something extraordinary. In September of 1984, he had developed a way to read patterns in human DNA that are different for almost every person alive. He called it genetic fingerprinting. On a sheet of X-ray film, a person's DNA showed up as a ladder of dark bands, like a barcode. No 2 people shared it, except identical twins. Think about what that means. A single drop of blood or one trace left at a scene could now be matched to one human being out of billions. But so far, it had only been used to settle questions of family, who was related to whom, an immigration case, a paternity dispute, quiet work in a lab. It had never been used in a murder case. Not here, not anywhere in the world. No court had ever heard the phrase genetic fingerprint. The police bring Jeffreys the teenager's blood and the samples from both murdered girls. The plan is simple: confirm the boy and close both cases at once. Jeffreys runs the test, and the result is not what anyone expected. The DNA says 2 things. 1, the same man killed both girls. The police were right about that. 2, that man was not the teenager in custody. His DNA didn't match either crime scene. He hadn't done it. The boy had confessed to a murder he didn't commit, and the test that was meant to convict him set him free instead. He became the first person anywhere in the world cleared of a crime by DNA. The very first thing this science ever did in a criminal case was prove the police had the wrong man. Hold on to that. The killer's profile is now sitting in a lab, the wrong man is free, and the right man is still out there, somewhere in those villages. Stay with me, because this is where it gets strange. The first DNA manhunt ever run, and the trick that beat it. If you like a case where one small detail decides everything, take a second and subscribe. It genuinely helps. So now the police are in a strange spot. They have the killer's genetic fingerprint. They just don't have the killer. They have a profile that belongs to one man in the world, and no name to put on it. So they try something nobody had ever tried. In January of 1987, they asked the local men to come forward and give a sample. Every man in the 3 villages, aged 17 to 34, blood or saliva, voluntary. It's the first mass DNA screening in history. Over the following months, more than 5,000 blood or saliva samples are collected. Now here's a detail people get wrong. They don't run the full DNA test on all 5,000. That test is slow and expensive, so they use the samples as a funnel. First, they check each man's blood group against the killer's. Only the small share who match that group move on to the actual DNA stage. It's a smart system. Cast a wide net, then narrow it to the few who could really be him. The villages line up. Men give blood at schools and village halls. And the screen returns nothing. No match. Not one. Out of thousands of samples, the killer's fingerprint never turns up. Think about how that must have felt. Months of work, thousands of men, the most advanced tool on Earth, and the column where the answer should be is empty. Which can only mean one thing. The man they wanted never gave his own blood at all. One of the men asked to give a sample was a baker named Colin Pitchfork. He lived in one of the villages, he was the right age, and he fit the screen exactly. Pitchfork did not want to give his blood. He had old convictions for indecent exposure, and he wasn't about to let the police take a closer look at him. So he found a way out. A staggering one. He talked a workmate from the bakery, a man named Ian Kelly, into taking the blood test in his place. Read that again. He didn't run. He didn't hide. He stayed in his own home in his own village and sent a substitute to walk through the manhunt for him. The cover story was clumsy, but it worked. Pitchfork said he was helping a frightened friend, a man too scared of being wrongly accused to give a sample himself. To make it work, they doctored a passport, swapping in Kelly's photo under Pitchfork's details. Kelly walked in, signed as Colin Pitchfork, and gave his blood. The sample was tested. It didn't match the killer, of course. It was Kelly's blood, and Kelly hadn't hurt anyone. So on paper, Colin Pitchfork was cleared. The most powerful test ever invented had just looked straight at the killer's name and waved him through. And this is the thing to understand. The science wasn't wrong. It did exactly what it was built to do. It read the blood in front of it perfectly. The blood just belonged to the wrong man. And there was no test on Earth that could catch that. A swapped sample looks exactly like an innocent one. The forensics had no way to see the lie. Only a person could, and for 6 months, nobody did. Then, in August of 1987, Ian Kelly went out for a drink. He was in a pub in Leicester with people from the bakery, and at some point in the evening, the talk turned to the police screening everyone had been through. Kelly said something he should never have said. He told the people at the table that he had taken the blood test for Colin Pitchfork. He wasn't confessing to a crime. He thought he had done a favor for a workmate. He said it the way you'd mention any odd errand. But a woman at that table heard it, and it sat wrong with her. She knew what the screening was for. 2 dead girls, and here was a man saying he'd stood in for someone else, and signed another man's name on the form. Why would an innocent man dodge a test meant to clear him? Why send a stand-in, unless the real blood had something to hide? She couldn't let it go. For weeks, she carried it. Then, in September, she went to the police and told them what she had heard in that pub. And that was the crack. Not a fiber, not a footprint, not the most advanced forensic test on the planet, a sentence said out loud over a drink by a man who thought he was helping a friend. The police pulled the thread. They confirmed the woman's story, and on the 19th of September 1987, they arrested Colin Pitchfork at his home. This time they took his own blood, his real blood, and they sent it to Alec Jeffries, the man who had started all of this. The result came back with no doubt in it at all. Pitchfork's DNA matched the semen from Linda Mann, and it matched the semen from Dawn Ashworth. The same genetic fingerprint that had cleared an innocent teenager now pointed exactly at the guilty man. Faced with it, Pitchfork confessed to both murders. 2 girls, 3 years apart. 1 man. The killer the science had been chasing had lived in those villages the whole time and had stood in the screen and slipped it. And here's the part worth slowing down on. Look closely at what the DNA actually did and what it didn't. The DNA did not find Pitchfork. It couldn't. For 6 months he was a cleared man with a clean sample sitting on file. What found him was a human slip. The substitution was beaten by a careless sentence, and that careless sentence reached the right person. What the DNA did was confirm him. Once they had his real blood, it proved his guilt beyond any argument, and it proved it for both girls at once. Catching him was human. Convicting him was science. And it's worth being precise about which one did which, because almost everyone remembers it backwards. There's a second thing this case quietly settled, before it convicted anyone. It freed a man. The same drop of evidence that traps the guilty can clear the innocent. An interrogation produced a false confession. The science overruled it. That on its own was a warning the whole legal world needed to hear. In January of 1988, at Leicester Crown Court, Colin Pitchfork pleaded guilty to both murders. He was sentenced to life in prison, with a minimum term of 30 years, later reduced to 28 on appeal. He was the first person in the world ever convicted of murder on DNA evidence. The case that proved an innocent man's innocence had now convicted its first killer. And the technique that did it, genetic fingerprinting, went on to become the backbone of forensic science everywhere. It all started in 3 small English villages, with 2 girls and 1 drop of blood. If this is the kind of case you like, where the smallest human detail outruns the biggest machine, then subscribe. You'll want to be here for the next one. Step back and look at the whole shape of it. A new science arrives that can read a killer off a single drop of blood. The police build the first manhunt in history around it, and the killer simply declines to give his blood. He hides behind a friend's arm, and the friend's clean sample clears his name. The lab can't see him. The barcode can't see him. The wide net passes him through. The flaw was never in the science. The science was perfect. The flaw was in the one place no machine could reach. A man telling the truth to the wrong people. What the trick could not survive was one man talking too freely in a pub, and one woman deciding that what she'd heard was wrong. Colin Pitchfork is remembered as the first killer caught by DNA. He wasn't. He was the first one confirmed by it. The catching was done by people. The science could tell the world exactly who he was. It just needed someone, anyone, to hand it the right drop of blood, and in the end, a careless sentence did what 5,000 samples could not. The most advanced test in the world couldn't see him. A careless sentence in a pub could. That's the case. If you see things other people miss, hit subscribe. Case Vault drops a new one twice a week, and the next crack is sharper than this one.